Assalamualaikum, my name is Zikri bin Rasli and my meeting number is 205977. Today I'm going to present for Lab 10, which is thermal expansion for solids and liquids, for video presentation in Mechanical Engineering Laboratory 2. This is our team's result that we gained by doing an experiment that we recorded the values for each increment of 10 Celsius for 3 types of solid tubes, which are for aluminium, brass and copper until 80 Celsius. But in this experiment, we only achieved 78.5 Celsius. This result shows aluminium has the higher change in length for the measuring tube, followed by brass and copper. After that, this is the plot graph for the relationship between length and temperature for aluminium, brass and copper. The coefficient of linear expansion is then calculated from the experiment data using the formula. The coefficient of linear expansions equals the change in length that is divided by the original length times the change in temperature. So, this is the result to be compared with the theoretical values. The purpose of doing this testing is to measure the coefficient of linear expansion so we can know how much developed part will remain dimensionally stable under temperature variations. Next, to compare the result to the theoretical values and to understand how thermal expansion works, which is thermal expansion occurs when an object expands and become larger due to a change in its temperature. Lastly, to identify what is suitable material for the application that we want to use because of different materials expand by different amounts. To relate to engineering application, rail track can be used as an example because all metals expand when heated. So the railway engineers always leave a small gap between two rails to compensate for the expansion of the rails during the hot days and the contraction of the rails during the cold night. Next, thermal expansion joints in the Auckland Harbour Bridge also allow the bridge to change in length without buckling. So, I think that's all the explanation for Lab 10 from me. Thank you.